Hi, welcome to the next part. In this part, we will see the Coulomb's law. It's a very important law, and that is just a start of electrostatics when we are able to calculate the forces between the charge. Because we know the two charges like these, two positive charges, they will repel each other. Now the question is how much this force of repulsion will be. What will be the value of this? So the calculation part, the formula part is given by the Coulombs, which is a scientist name, and we call it as a Coulomb's law. So let's explore this. Few things we already know. So we can use our common sense here. If I ask you in the first case here or second case, where is the force maximum? So you'll say because they are very close, in this case, the forces will be more, and because the distance is more, in this case, the forces will be lesser. So this is the same example. We can understand if there is a north-south magnet, if they are far away, the forces will be less. We have already have experience of that. So similarly, we can think of this also. So similar kind of logic we can apply here. See the second example here. Let's see the third and fourth case. In this, what I've done, I've not changed the distance, but at the fourth case, if you see, the charges are more. So in this case now, there will be more force. Why? Because the charge has increased. So we can roughly say, so if we are increasing charge, what is happening? The force is also increasing. So this is our observation. If there is more charge here, for example, it will exert more force. And the second is, if we are increasing the distance, the reverse is happening. Reverse means the force is, instead of increasing, it is decreasing. If two magnets are far, far away, what will happen? The forces between them will decrease, reduce. So this observation, if you see, you will see the formula next of Coulomb's law, and it will say the same thing, but in a different way. Let's explore. So let us explore the Coulomb's law. So Coulomb's law, this Coulomb is a scientist name. So this law is given by the Coulomb. So that's why we call it Coulomb's law. So what Coulomb's law says is the same thing. If there are charges, say Q1 and Q2, and they're separated by some distance, so the force will be directly proportional to their multiplication. So if we increase charges, the force is increased. That is what our observation also was. And the second thing, if you increase the distance, if you move this charge Q2 say far away, so the forces will reduce because the distance between them has increased. And if you see the formula below for this tells the same thing. It is giving the magnitude of force, and if you see there's a constant and there is a multiplication of Q1 Q2. If you increase this, the magnitude of force will also increase. If I increase Q2, then also the force of between them will increase. And if I increase this distance, if I increase the distance, so because it is in denominator, so this force will reduce. It has an inverse relation. So see how beautifully our common sense and the Coulomb's law mathematically tells us the same thing. So let us explore now what in detail what these all values are. So what it gives us the magnitude of the force between 2 point charges, and also it tells about the direction. So first let's explore how it gives the magnitude. If you want to find, first let me create a diagram also. Let's say here is a Q1 charge and here is a Q2 charge, and the distance between them is R. So the magnitude of force which they will feel, let's say they are same charges, so I can show the direction like that also. So this force which both of them will feel will be calculated through this formula. So what this formula is, at the left side you can see is the force, magnitude of the force. This we call Coulomb's constant. Coulomb's constant. These are 2 point charges. Point charges. So the Coulomb law works when charges are given as a point, not in the continuous distribution. It does not work there. So point charge means just from a dot we can represent that charge. That this is say Q1 charge, and this dot I can represent it as like Q2, or I can represent it by a point. So that's why we are calling them a point charges. So let's go next. What else? This is R is the distance between these 2 point charges. So if we know this, we can fit these values in this formula and we can calculate it. Also, it tells the direction. How we'll get to know the direction? Because the magnitude, this formula will not give you direction. Because see, here I've used these bar lines. Can you observe this? So this tells that when you are using this formula, you just need to put values in magnitude, not the signs. We will take one example where we'll understand this, how we can use this formula. But remember, don't need to put signs here like -3 Coulomb. You should not use -3 here, just use 3 for -3 Coulomb. So, and this K constant has a fixed value. We will also explore when we are doing some example. And let's go again in the direction where we were. So the direction will be radial, and radial means along the line joining the two charges. So that is a common sense if these are two charges. Okay, and if I say you where is the direction of force, nobody will say in this direction because they will follow this line joining both charges, and it will be along that. And that is our common sense. We can find it like if they are q1 q2 are positive charges, so we know they will repel, so the direction will be in this case will be radially outwards. And if they are like one of them is positive, again the force will be on the same line but in inward, radially inward. Radial means it will be always along the line joining them, and depending on what kind of charges are there, if they are positive positive they will repel, if they are positive negative they will attract. That we can get from our common sense, from our previous classes knowledge. So this is how we calculate the Coulomb's law. Here are some points which we should note and we should not get confused on. So these are the two important points. First thing is these are action reaction forces. They must be equal and opposite. So let me take an example. Like for example, here is say 10 coulomb charge. Let's say it is Q1, and here is a second charge Q2, which is only of say 2 coulomb. Let me draw the line joining two charges or radial line. Let's say it is R. Now, if you see here, it sometimes we say that it will be exerting. They are both equal positive charges, so they will repel. It will repel, and it will repel. But sometimes in our mind we get intuition because this charge is small. It is 2 coulomb only. It will have more force because this is a big charge. It will exert a big force on it, and because this is a big charge, so this charge will exert a smaller force here. So that is conceptually wrong. They are action reaction forces. Both charges will experience same force. So Newton's, if you see the third law, action reaction, every action has an equal and opposite reaction. So if I want to correct this now diagram, so if I'm drawing like this much force, exactly equal and opposite force will be in this side, action reaction pair. Okay, let me draw equal like that. So these arrows will not be shorter than one another. They'll be equal, but of course in opposite direction. So when you are calculating the force magnitude, you are calculating this also and you are calculating this force also. They will have the same force. Both charges, irrespective of whatever the charge is, both will feel the same force. So that is one thing we should be remembering. And second thing is, don't get confused. Don't put signs in the Coulomb's law. Then you will start handling the minus signs. No need. Just calculate the force, and by common sense, seeing the charges, they are positive or negative, find the direction. So let's do one example so that we can understand this question, this calculation better. So if there is one charge Q1 is 2 coulomb, let's solve the same question, and the second charge is say 10 coulomb. The distance between them is say 2 meter. So if asked what will be the force, so let's do it. First we will draw a diagram. Let's say this is Q1, 2 coulomb, and here is Q2, 10 coulomb, and here is a line joining, radial line. This is the line which is given 2 meter of length. So distance between them is 2 meter. So let's solve it. We will apply Coulomb's law. We'll use Coulomb's law, which says the force will be equal to K multiplied by magnitude of Q1 multiplied by magnitude of Q2. Magnitude means just don't care about their signs. Whatever the magnitude is, you need to put that value, and R square. So what will the value of Coulomb's constant? That is a fixed value. I will note it down here. 9 into 10 raised to the power 9, we take it around that value, and there will be units also, and you can calculate the units of this Coulomb's constant from this formula. See, if you want to calculate the units of this K, what you need to do is you have to just arrange these units to the other side. For example, at this side, what is the unit of force? Just write force. It is Newton, so Newton will be there. Then what is the unit of Q1 and Q2? They are just Coulomb, so its unit is Coulomb, Coulomb square, and while they are going other side, they will go down. So we will say Newton divided by Coulomb square. There is This is now the distance units are in meters in SI, so it will go up, so it will be meter square. So like that, you don't have to remember these units, you can simply calculate it from the formula. So this will be newton meter square divided by Coulomb square. So these units, no need to cram them, you can calculate from here. Okay, so this is the value we can put, and now let's put the values and calculate. So it will be 9, use a different color, 9 into 10 raised to the power 9 into 2 into 10. Both are positive, so no need to, we just need to put the values. Now square of 2, so it will be 2 squared. So what will become? Okay, this will be 20, 180 into 10 raised to the power 9 divided by 4. Let me solve this. It will go from 4, then this one, and the answer will come 45 into 10 raised to the power 9. If I want to write in the scientific notation, I will shift a decimal from here to here. I will say 4.5, and I have to increase the power. What will be the units? We are calculating, remember, force. So the units also will be the unit of force, which is Newton. So this much of force will be experienced by this much of charge. Okay. What about the direction? So direction, they are both positive, so they'll be repelling each other. So I'm drawing here. So this, and I will make sure the other arrow is also equal and in opposite direction. So this force is, which we have calculated, 4.5 into 10 raised to the power 10 Newton. This force is same, it will experience the same force, but of course in opposite direction. So this charge will be experiencing this force in this direction, and this charge, Q2 charge, will experience in this direction. Note that we are keeping these arrows or force in line with the line joining between these two charges. That is what we meant for radial lines. Let's do one more question. Now, if Q1 if Q1 charge is say 2 Coulomb and Q2 charge is minus 3 Coulomb, and distance between them is 2 meter. Again, let's change the distance then, this time 3 meter. So what will be the force? Let's use Coulomb's law again. Now I'm directly putting values here. Force will be Coulomb's constant, 9 into 10 raised to the power 9 multiplied by magnitude of Q1 multiplied by magnitude of Q2. See, I'm just using value 3. We can use minus 3 also. That's not a problem, but you will get a force in negative. So I don't want to, have that. It will just show that it is an attractive force because they are positive and negative. They will attract. But if you're calculating just magnitude of the force, just calculate it, just putting the magnitude of the charges. Don't put signs and calculate it. And then later you can find the direction by your common sense. So now r square will be square of 3. It will be 9. That is good because we have a 9 in above also, in the numerator also, so that will be cancelled out. So this will become 9 we can cut out, so it will be 6 into 10 raised to power 9 Newton. So this is our force which will be experienced by these charges. Let us draw a diagram so that we know how the forces are, what are the direction. So this is the Q1 charge of 2 Coulomb, and this is the Q2 charge of minus 3 Coulomb. This is the line joining them. It has to be straight. I'm just roughly drawing it. It has to be straight. Okay, now let me show you the direction. They are opposite charges, so the direction of force will be radial or in the line, along with the line of which is connecting both charges, and they'll be again equal and opposite. So if I draw like this, it means this charge is experiencing more force and this charge is experiencing less force. So we should be careful about it. Just roughly keep it equal. And what is the force? This force on charge Q2 is same in magnitude. This force is also same in magnitude, but they are in opposite direction. So this is the small recap of Coulomb's law. Thank you.